Hey team, welcome back to my channel. The source code for this video is available on my GitHub account. Go to github.com/softwareNuggets. Go to repositories, then look for assembly, and then at the very bottom you'll see this lesson 11, printf 6 registers 3 stack. Click that, and there's the source code. You got it. Here I'm declaring the format specifier for the printf function. You can see that these %s, ld, and d statements are placeholders for values that will be used in the printf function. The first 6 parameters must come through registers, and they have to be in this order. As you can see in the first register, RDI, I'm putting actually the format specifier into that. And RSI, I'm putting the file name. You can see that right here. Then RDX per 1024, that will represent the size. 2025 to 28, that's the date. So that will be year, month, and day. Those 6 arguments will be stored in registers. And we can't use any more registers for this problem yet. I have 3 more placeholders. To allocate space on the stack, we must be 16 bytes aligned. Notice we need 3 variables. That would be 24, but that's not 16 bytes aligned. Here you can see in green, I'm using 32 bytes. As you can see on line 14, I'm going to allocate 32 bytes on the stack. Then on line 25, 26, and 27, we are actually just going to write the values directly to the memory addresses. Remember, RSP is our register stack pointer. Now here you can see that I'm actually not going to change that value. I'm just going to increment. So RSP plus 0 offset, I want to store 15. At that same RSP plus 8, I'm going to store 30. And once again, at that same RSP plus 16, I'm going to store 45. Now, it doesn't matter what order I do these. I could come down and just change the order completely. And notice it appears that I'm going from top to the bottom. But it doesn't matter because these are themselves memory locations on the stack. So once again, don't worry about going high to low or low to high. It doesn't matter. Now, one thing we do need to know though, RSP sub 0 is where the printf function looks for and then will work its way up for our additional parameters on the printf statement. So printf knows that. They know to look for this location right here. And that's all you really need to understand about this move keyword, that's 8 bytes, onto the stack. Now, once we get those loaded up, we can actually execute the printf statement. Now, before I execute that print statement, I'm going to initialize EAX register to 0. So this command just zeroes out EAX. We're going to call printf. We're going to send the 6 registers plus the 3 variables that we put on the stack. It will execute because we have RSP plus 0. And then when we're done, I'm going to just reset my stack, give the memory back to the operating system, and get out of here. Here you can see I'm going to use the ls command, -al learn star. These are all my files. Now when I say cat learn underscore printf.sh, that shows me the contents of this file right here. And you can see here that we're going to use the assembler nasm, and I'm just pretty much going to take this asm file and I'm going to create a .o file, and I'm going to put some debug information in there. Then I'm going to use gcc and I'm going to compile that, which turns into that .o into the executable. You can see that here. Now to execute this program, all you do is say /learn, enter, and there's our output. And notice that we have our 1, this whole thing is 1, right? It was the format specifier, file name, file size, Year, month, day. That right there represents 6 registers. And then, hour, minute, second were given to us through the stack. And there you have the printf function in assembly language.